Okay, here we go. Hey, quiet. Listen. Make sure your phone is completely put away. Don't have any distractions. Okay, number one in the green, first item. Look at me. A common critical mistake students make is they will start the problem wrong for a very simple reason. They'll do all this work, they will spend a lot of time and be completely off track. Okay? You've got to make sure you never mix up when they're asking for absolute max versus when they're asking for relative max. And it's easy to determine. You read the problem, you can tell no one has any problem noticing that they're looking for the max. But you've got to make sure if they don't use the word relative or local, then it isn't relative or local. Like if it's relative or local, they have to use the word. But if it's absolute, they don't have to use any special word. They just have to generally talk about a maximum. So nowhere in this problem does the word relative or local appear. So I know right away I am not talking about relative or local max. I am instead talking about absolute. It's one or the other. Just figure out which one it is. Question. Okay. Once I know it is absolute max, my brain goes to what I call the min-max theorem. I think the theorem is more easily understood if we just talk about it versus write it down. So I know I'm looking for the max of something. In this case, it's the max of V. So all I have to worry about is, okay, max of V. Well, I need to know at what time should I first start looking. So in this problem, I'm supposed to start looking when time is greater than 0. So I don't look for any times equal to 0 or negative. That means at that very beginning time, so max of V could occur. Doesn't have to occur, but it could occur at a time of just barely more than time 0. That could be where the maximum of V occurs. Because the maximum can always occur at the very beginning time that you are analyzing. Question. The maximum of V could also occur at the very last time you analyze, which in this case there is no specified last time. So this is highly likely to not be the answer. I don't really think there's much chance. There is a very rare chance, but I've actually never seen it happen on the test. So we worry about the very beginning time. We worry about the very last possible time. Those could be the times when V is greatest. But we also must worry about, hey, maybe in between those two times, V has some relative maxima. At any of those spots, V could also be greatest. That's the min-max theorem. You have to have that memorized. Here's another way of saying the min-max theorem if you find it easier to use that. But either way, question. You weren't bothered by anything. Chance to write that down, it's a little wordy. Okay, so one of the challenges of problem number 1 is you have to keep switching your focus. Like we start our focus right here on this idea, the min-max theorem. Now we're going to temporarily shift our focus just a little bit. We're going to focus completely on this idea. So for a moment we stop thinking about anything else and we just focus on that. And so we need a sentence to help guide that work. Since I underlined that in purple, we'll have Carrie Ann give it a shot. What sentence would you have me write, Carrie Ann, that's going to help me figure out the purple, like where V of t has a relative max? Like the overall problem is to find where V of t is absolutely the highest, but temporarily I set that aside and I just focus on the purple. So what sentence might help me figure out whether or not V of t has a relative max?
I don't know.
Okay, 2 points for staying with us here. Anna, what would you say?
V of t has a relative max when v prime goes from positive to negative.
There we go. 2 points for Anna. So that's where we're going to focus for a while. You may need me to talk more about that. So knowing that, Ethan, what would you propose we do?
Start plugging in values into the equation to see when it changes from positive to negative.
2 points for good thought. That's a common mistake, to be fair. So Ethan, Valletta, what's the error that's occurring in that thought?
I do not know.
Okay. Points for staying with us. Sabrina, what's the error in that thought? Yeah, 2 points for that. Ian?
See where v prime changes from positive to negative.
Yeah, we wrote right here, we want to see when V prime changes positive to negative. So it's not going to do a whole lot of good to plug things into V. We're looking for when V prime changes positive to negative. So 2 for Ian. So Maddox, what would you suggest?
Take the derivative of v.
Yeah, we want to take the derivative of V. So we want to apply the d over dt operator, 2 for Maddox. D over dt operator to both sides of this. Questions? Anyone feel like it's not making sense, so I need to say it in a different way? Please, Paige.
Sorry, so why are we looking for the relative max if it's absolute to the absolute max?
Because the min-max theorem tells us, hey, the absolute max of V could be at the very first time we are supposed to look at. It could be at the very last time we're supposed to look at, but it could be somewhere in the middle. Where would it be in the middle? Where V has a relative max. Make sense? 2 more. So Haley, what would you tell me to write down? And don't forget, V prime and A are the same thing. So I'm going to write V prime for this problem because it's more relevant, but A is the same thing. So Haley, one more time, sorry.
T times d of the ln t.
Nicely done, 2 points. Golden, what would you have me write next?
Minus ln of t times dt over dt.
2 points. Drex, what would you have me write next?
All be over t squared.
2 points. Question? Cool. Stella, now what would you tell us to write?
V prime equals, would ln of t just go to ln?
No, but that's okay. So right here, we've got to use the proper rule. So what's the derivative of the ln of something?
ln, wait.
Oh, sorry, just not remembering quite right. Look at your green sheet. It's 1 over the something.
Yeah, 1 over t.
There we go. It'd be 1 over t, then dt dt. So here we go, 2 for Stella. So we have V prime is going to equal t multiplied by 1 over t dt over dt. Now what, Tessa?
Then you do minus and then just ln t over t squared.
2 points. When you need to talk about anything a different way. That
You said A a second ago, talking about V prime and T, what were you talking about?
Yeah, the derivative of velocity is also known as the acceleration. So we don't need that in this problem, but it will show up all year that you need to remember that. Important. So Ethan, Valletta, what would you have me write now? Okay. Hang in there, point. Let's go to Hunter.
Would you just solve that down?
Yeah, it's too tempting to leave it alone. We want to write it in a way that's more easily understood. So what would you have me write?
V prime of t equals.
That's a weird T. Hold on. Marker glitched. Keep going, Hunter.
Would you factor out a t?
You can't.
Not yet. Because
Well, I can't ever, because it's not ln times t, it's the t inside the ln operator.
Okay.
And so it's not accessible, it's not a factor. So what would you write?
So just 1 minus
There you go.
ln t over t squared.
2 points, nicely done.
Sorry. that took-
No, you did fine. It doesn't matter that you need to pause and think for a minute. What's crucial is you thought through it properly. It's good work. Yeah, time is not an issue on the AP test. Hey, everyone, listen. It is not the ACT, where you must race to get a good score. You don't race on the AP test. If you do, you'll get a bad score. You just go methodically, just like Hunter did. It's perfect. Just think as you go. It's perfect. There's no reason to hurry. We good? Okay, we have our formula now for V prime. So we're going to take that formula. We're going to do something with it now. So let's write that on the next page here. So V prime of t is equal to 1 minus natural log of t all over t squared. Okay, everyone needs to make the following flashcard. It must be memorized. If it is not memorized, I guarantee you'll miss at least 2 questions on the next test. It's a total of 6 points, remember? So it's not that hard to memorize, but you must take the effort to memorize. The card on the front should say this: natural log, let's go to the new page here. The card on the front should say natural log of e to any exponent is what? That exponent. So on the back of the card, I put that rule. And now I give some examples of where you're going to use the rule. And you'll need to remember these examples, otherwise you'll have trouble on about 2 or 3 questions on the test. So, natural log of e squared is just what? 2. Now the next one follows the pattern, but you have to remind yourself that natural log of e to the first is just natural log of e. So natural log of e is simply 1. We're going to talk about that. We keep following the pattern. So next one would be natural log of e to the 0 power. But e to the 0 power is 1 itself. So that's just natural log of 1. Hence, natural log of 1 is 0. You have to know this pattern for about 3 problems on the next test. And I'm not going to test you on the pattern. Like, you'll just have to say, wait a minute, there's this, yeah, I got to remember this. You just got to come out of your brain. You can't be like, not testing you on this, that's too easy. So then we go natural log 1 divided by e, which actually is the same thing as natural log of e to the negative 1. Therefore, that is equal to negative 1. And one more item to complete the pattern. Natural log 1 over e squared would be natural log of e to the negative 2, which is simply negative 2. These decimal values are, this is natural log of about 9, natural log of about 2.7, natural log of 1, natural log of about 1/3, natural log of about 1/9. So natural log of about 9, natural log of about 3, natural log of 1, natural log of 1/3-ish, natural log of about 1/9-ish. Okay. Questions? Solid. So now we have that. We go back to here. And our guiding sentence was the purple. Or sorry, the purple. Here was our guiding sentence. V of t has a relative max when v prime changes from positive to negative. So now Brooklyn, when you're taking the AP test, and if it's the written section, we're trying to figure out when v prime is positive or negative. They're going to give you points for writing a very special sentence here in black. What do you write in black? That is outstanding. And that alone often will get you a point. 2 points for Brooklyn. So then we put in the old when. We'll get Mary to help me here for a second. When x equals, t in this case. When t equals, so you look at the top and bottom separate, Mary. And if we can make the top equal to 0, then v prime will equal 0. So Mary, is there a value of t which will cause the numerator of v prime to equal 0? Close. We want the top to be 0. So Mary, what do we want ln of t to equal? 1. So now you look at your flashcard and figure out what value must t have so that ln of that value is 0. E. So you know that v of t is equal to 0 when t equals not 0. That was my mistake. When t equals e. When t equals e, the top here will be 0, and therefore v prime will be 0. 2 for Mary. You need me to talk through that a different way, please.
Would you need to include t equals 0 to account for the undefined in the first half of the sentence?
Perfect. We looked at the top alone. We figured that out. Like when the top is 0, v prime is 0. Top is 0 when t equals e. Then Dylan figured out, hey, if t is equal to 0, the bottom will equal 0, which means v prime would be undefined. That's perfect. Anybody else? I'm going to say it in a different way. Okay, so we've got our money thing here. This is going to get us some points right here. So now it's time to make the sign chart. So Charity, what are we going to chart in this case?
What do you mean by charting?
What I mean is we're making a sign chart, and the sign chart must track 2 different values as they relate to each other. What 2 values are we going to place in the chart? And it's all about the guiding sentence again, which was right here in purple. So according to this guiding sentence, what kind of sign chart should we make?
I think, one side would be t, and the other side would be v of v prime.
Perfect. We want a sign chart that is going to track t compared to v prime of t. Because we're trying to figure out when the signs of v prime are either positive or the signs of v prime are negative. Perfect. 2 points for Charity. So come over here. We'll go to Maddie. So we go t and v prime. And what do I put first in this chart, Maddie?
0.
2 points. Questions? Oh, please.
What if you want to leave space above the 0?
2 points for Maddie. Usually, yes. In this instance, no, because they said I don't want to deal with any times that are less than 0. Good work. Good work. Anybody else? So, Sam, what do I put in the chart now?
That 0 is 0.
So at time equals 0, v prime is undefined, actually. And at time equal e, Sam, v prime is
0.
0. 2 points. Questions? Perfect. Jackson, now what?
Just find v prime of 1 and 3.
2 points for Jackson. There's a reason why we don't want to use 3 though. 3 is greater than E because E is about 2.7. 3 is bigger than 2.7. But you are not expected to have memorized the natural log of 3. So you don't want to use 3 because you don't know what the natural log of 3 is.
Can you do like E squared?
Perfect. That's the purpose of the card. Is for you to remember, hey, I don't want to use time equal 3, but I could use time equal E squared. E squared is greater than E. 2 more for Jackson. E squared is greater than E. And I can find the natural log of E squared. So that's going to work. Questions? Let's go back to Carrie Ann. So Carrie Ann, I'm trying to make my V prime chart here. So that means I take the time equal 1, plug it into V prime, just little by little. So Carrie Ann, looking at that flashcard, what's the natural log of 1?
Is it 0?
Perfect. So we get 1 minus 0, which is a positive on the top. 2 points for Carrie Ann. Then Paige, what's the bottom going to be?
0.
So we're taking time equal 1.
Oh, it'd be 1. Sorry.
There we go. Plugging it into V prime. The bottom will be what again, Paige? It'll be 1 on the bottom. So positive. Hence, overall, positive. 2 for Paige. Questions? So Claire, we now plug in an E squared. So natural log of E squared, Claire, will be 2. Therefore, 1 minus 2, Claire, is negative on the top. And what will the bottom be, Claire? Positive, because E squared squared again is still positive. 2 points for Claire. Questions? All right, here's what we know. We just made a sign chart of V prime. I can now draw a different picture if I choose, don't have to. I could draw a picture of V. Because I now know that V starts somewhere. I don't know where V starts. Without some other work. So V starts somewhere. Raise your hand, please. Don't say it out loud. What does V do? Does V stay flat? Does V go up? Does V go down? What happens to V? Hands up. Value V's got to start somewhere. This is, don't get mixed up. This is V prime. This is V. So the V starts at some value, but I now know what V does. What does V do? Go up, go down, stay flat. Jason?
It increases, right?
Yep, it says right here, V prime is positive. So V prime is positive, V's got to go up. Jason, tell me when V prime stops going up.
When you hit 0.
I said that badly. When does V stop going up?
When it's E.
Time equal E. So at about time equal E, or 2.7-ish, V stops going up. 2 points for Jason. Questions? So then Jack, then what happens to V?
And then it decreases.
V goes down. Jack, when does, it's kind of a trick question, when does V stop decreasing?
Is it infinite?
Never, just keeps going. 2 points for Jack. Biggest thing I worry about is you mixing up V prime and V. This is another great example of you can't just do work, you got to understand what you're talking about. But you need to talk about it differently. Like we spent a lot of time analyzing V prime, but it was all so we could understand what V is doing. Okay? So raise your hand and show me on your hand who knows the correct answer. Like show me on your hand who knows the correct answer. Show me on your hand what is the correct answer. By doing this, give yourself 3. This is an example of where the absolute, listen to the words, the absolute max of V occurred in exactly the same spot as the relative max of V. They occurred in exactly the same place. That doesn't always happen, but in this case it did. Questions? Something else to be cautious about. They sometimes ask for where the relative max occurs, which means they're asking for a time or an x value. But they often ask for what is the relative max. So if they said, what is, not relative max, what is absolute max, sorry. In this case, the relative and absolute are the same. What is the absolute max of V of t? That is also, no it isn't actually. Who knows the answer to that? Hands up. We know where the absolute max of V occurs, but what is that maximum value of V? For hands. It's not that hard. It's not hard at all. What is the absolute maximum value of the velocity? All you know now is the time when the maximum occurs. What is the maximum? Let's go, Jess. Tell me what you're thinking so I can pay you. Like, where did you get the 0?
Just from the
Right here. So what you found was 2 points. You found the value of V prime at time equal E. The value of V prime at time equal E is 0. That is different than the absolute max of V itself. It is different than V prime. So who knows that one? Absolute max of V itself. Let's go, Caleb.
It's 1 over E.
So Caleb says, I need to know the value of the velocity at time equal E. That's the time when the velocity is greatest. So he uses the formula for velocity. If you knew that, give yourself 2 points. Caleb gets 3. Natural log of V is equal to 1 over E. That is a commonly asked question on the test. Question? You need me to talk through it differently. Please.
So what is the difference between like relative and absolute? Because both of them are, you know, using out the same equation, using it from like a positive to a negative, the sign chart.
2 points per 100. And you've got to get this thoroughly memorized. It is a common place to mess up, and it's a place where no one should mess up because it's not complicated. It's just, you got to remember it. If they say, when does V have a relative max, you should focus on this black box and nothing else. If they say, when does V have a relative max, you only focus on that black box, nothing else. That's it. Questions? But if they say, looking for where V has a max, so they did not use the word relative, you just have to focus on one more thing. Not only do you focus on the black box, you must also focus on, well, what was the first time they said I should consider? Oh yeah, time equals 0. Maybe that's where V is absolutely greatest. What was the last time I should consider? Oh yeah, it's this one. So now you consider 3 things. First time, last time, and black box. Or relative max of V. So relative max, only look at relative max, not the ends. If you're looking for a relative max will never occur on the endpoints. Absolute max could occur at either.
So for the absolute max, you do like a chart for both of them, but since it's infinity, you don't have to, or what?
So for absolute max, what we do is we do the sign chart for the relative max. If we don't get something so clean like this one, where, oh yeah, V just goes up, V goes back down, so it's pretty obvious the highest point on V is exactly where the relative max on V occurs. If we don't get something that easy, we have to go check the ends to see if that's where the max occurred. So just have to consider them. 2 more. Anybody else, please?
So you're checking the ends on the absolute max?
But not the
But
relative.
not the-
Yeah, relative, you do not worry about endpoints. So the relative max never occurs at an endpoint. Please.
And you just check the ends by plugging it in.
You plug them back into V. you go back to V, that's where you check that. Two more. 3 hours. Cool, next one.